I hope this slide is visible. In case you are getting any doubt difficulty, you should raise those doubts and difficulties in the chat window. Okay. Now this is the fifth lecture of discrete mathematics in continuation. So I hope that all of you have bought a separate notebook for discrete mathematics and you are keeping it with you while attending my lectures. Yesterday, the assignment number 2 is posted on your Google Classroom involving the various questions based on finding inverse, converse, and contrapositive of a given conditional statement. Then we are having a couple of questions related with logical equivalence as well. The deadline to submit that particular assignment is Thursday up to 5 p.m. You can submit your snapshot of the solution or you may submit in the form of PDF on the Google Classroom. That particular assignment will carry total 20 marks weightage out of your remaining assignments. Okay. So moving further, yesterday we had a discussion on the various connectives and their truth tables. Furthermore, we have seen the conditional statement can have its variants like converse and contrapositive. So I have tried to uh, combine the truth table of all the connectives. This will be the very important slide that you should remember throughout the discrete mathematics and in your further studies as well. So if we have been given two prepositional variables p and q with the truth values, what will be their conjunction, disjunction? I am talking about inclusive or conditional and biconditional. So if we are looking about conjunction, we will have resulting value as false in all the cases except when both the prepositions are true, then only I am going to have them. I would suggest you to take a snapshot or have such a table in your notebook. You have to remember the things while solving the actual problems. Okay. In case of P or Q, whenever both P as well as Q are false, then our resulting value will be false. In other cases, we are going to have. Okay. In case of conditional, we have discussed this yesterday. P conditional Q, I will have false only if first statement is true while second statement is false. In that case, I am going to have false. In rest of the cases, I will have true. Finally, P by conditional Q, or you may write like this, Q by conditional P. Both will be logically equivalent. Okay? If both P as well as Q are holding same truth value, it may be either false or true, my result is going to be true. If either is true or false, that means P is false, Q is true, or P is true, Q is false. In that case, I will have resulting value as a false. Okay. Later on, we had a discussion on converse and contrapositive. For a preposition P conditional Q, the preposition which is opposite of this P conditional Q, that is Q conditional P, is called as converse, and the proposition negation of Q conditional negation of P is called as contrapositive. Remember that this symbol is also known as negation. We can make use of tilde operator that I was discussing throughout my earlier lectures. That tilde operator is used for indicating negation. Along with that, you may use this operator for indicating negation, or you can write bar above the prepositional variable. For example, if I want to denote negation of P, I will say P bar. P bar indicates negation of a particular preposition variable. That means there are three ways in which you can represent the negation of preposition using this operator. This is known as tilde, using bar, or you can use this preceding a prepositional variable to denote a negation. Okay. Along with this finding converse and contrapositive, we had a discussion on how to find inverse of a conditional statement. So for finding inverse, you will simply negate the original statement. So I will say negation of P conditional negation of Q will represent inverse of a particular prepositional statement. Okay. Moving further, I hope now we are having almost 59 and my voice is also audible. Everything is going fine, is it? So okay. Is it? Yes. Okay. Okay. Moving further, I have got a few questions from students about yesterday's assignment. Okay, they were having some confusion related with, I guess, question number 6 or something, and about this symbols. I will be talking about solutions of each and every assignment once the deadline for a particular assignment is over. So you should not feel any ambiguity, any confusion. Somebody is asking. So, truth table for converse and contrapositive. We have seen yesterday. We could observe here P conditional Q and Q conditional P. These are not equivalent. That is the reason. Here we have written only P conditional Q. Here we are talking P by conditional Q is equivalent with Q by conditional P. But that is not the case with conditional. The truth table of P conditional Q and Q conditional P is totally different. Those are not logically equivalent. How about this? If we observe P conditional Q, the original statement form, and negation Q, conditional negation P, which is contrapositive, I could observe that the truth values of both of the statements are exactly same. We observe. So can I say conditional P conditional Q is logically equivalent with its contrapositive, which is negation Q, conditional negation. Yes, it is perfectly. I can say. Moving further. So this is the important part. Okay, and I expect that each and every one of you should write these formulas somewhere in your notebook, in your digital pad, or anywhere, because whatever problems that we are going to discuss further are based on simplification of prepositional statements by making use of all these formulas. So prepositional logic involves solving of complex prepositional statements into simplified statements using some of the existing laws. These laws are known as laws of prepositional equivalence. Why the name laws of prepositional equivalence? Because we are equating LHS with the RHS in terms of logical equivalence. The symbol here used is this biconditional. This denotes a logical equivalence. Yesterday I have shown you another symbol which is three horizontal lines. This is equivalent to this. Okay, you can use either this or this. Both are equal. You may either use this bidirectional arrow to denote a logical equivalence, or you can use three horizontal lines. So starting with first, law of idempotence. What do you mean by idempotence? Okay, we can say that P, a prepositional variable P, is logically equivalent with P disjunction P. Let us check if it happens to be. Let us say my prepositional variable P is having truth value T. Then what will be truth value of T disjunction T? It will be again T. So whether T matches with P? Yes. Hence we can say that P is logically equivalent with P disjunction P. This is known as idempotence, representing a prepositional variable in terms of its disjunction or in terms of its conjunction. That is the law of idempotence. You can easily check for conjunction as well. Let us say P is holding F. My prepositional variable P is having a truth value as F. What will be the truth value of F conjunction F? So if I say this F conjunction F, I'm going to have a truth value as F only. So can I say this? Yes, it is perfectly fine. P is logically equivalent with P or P. P is logically equivalent with P conjunction P. Law of idempotence. Okay, I hope this is clear. Moving further, we have seen addition, multiplication operators are commutative as well as associative. That means if I am performing addition of 3 and 5, what is the result? 8. If I write 3 plus 5, result will be 8. If I write 5 plus 3, what will be the result? Result will be 1 and the same. Okay, so change of positions doesn't affect your final result. That is known as commutativity. So you can observe P disjunction Q is equivalent to Q disjunction P. I can write in either way. My result will be 1 and the same. Let us say value of P is T, value of Q is F. So what is T or F? T or F is true. Value of Q was F. So F or T, the result is true. So this is commutativity of disjunction. P or Q is logically equivalent with Q or P. Same holds true for conjunction. P conjunction Q is logically equivalent with Q conjunction P. Again, someone may have a question in mind. What is the proof for this? How can I prove that this logical equivalence holds true? We have to simply construct a truth table for P or Q, construct a truth table for Q or P, and check out whether the truth values in the truth table for the corresponding expressions, that is P or Q and Q or P, are one and the same. Exactly, those will be same. Hence, we can say that P or Q is logically equivalent with Q or P, and likewise. Is it fine? Law of commutativity. Is it fine? Let me go back to this. Is it fine? Are you following? Are you writing in notebook? Even though it is covered somewhere in your earlier mathematics, I need you should write it somewhere in your notebook. आपलं लेक्चर कुठलं असं दुसरं नाही जिथे तुम्ही फक्त ऐकताय and you are perhaps so called recollecting everything by listening only. That will not happen with mathematical subject. Okay? Moving further, associativity. So whenever you are using braces to combine two or more expressions together, change of braces will not affect the final result if the operator used is one and the same. You can observe P or Q whole brace disjunction with R. If I write it like this, P whole disjunction with Q or R. This is known as law of associativity. Change of brackets doesn't affect your final result. How to validate this? Again, construct a truth table and check out the truth values. You will observe that truth values for left sub expression will be exactly same with truth values of right prepositional statement or expression. Just like it is similar to saying, if I perform addition of two numbers, let me go back to my notepad so that thing will be more clear. If I say 3 plus 5 plus 8, can I write it like this? 3 plus 5 plus 8. It is same like this. Instead of addition, we are saying either disjunction or conjunction. The final result is going to be one and the same. This is 5 plus 3, 8, 8 plus 8, 16. What is this? 8 plus 5, 13, 13 plus 3, 16. My result is not going to change at any moment of time. That is the law of associativity. Remember that the operator used within the braces and outside the braces is exactly same. This law holds true for disjunction as well as conjunction. Moving further, the famous law in the theory of logic known as De Morgan's law. This law deals with usage of negation. So what if I apply negation to P disjunction Q as a whole? If I apply negation to P disjunction Q as a whole, it will be logically equivalent with, we are applying negation inside the bracket, negation P, this disjunction, negation will be conjunction. Conjunction, negation of Q. Remember this, okay, this is very, very important that we are going to use in all our further examples. Okay. Negation of P or Q is logically equivalent with negation P, conjunction, negation Q. This is known as De Morgan's law. Negation of P, conjunction Q, whole, okay, bracket is used. So I will apply negation P. Negation of conjunction is disjunction, negation of Q. I hope this is clear. This clear. Okay. Shall we proceed? Yes, I'm proceeding. So up till now we had a discussion on law of idempotency, representing a variable in terms of itself using disjunction or conjunction. Law of commutativity, change of places doesn't affect your final result. Associativity, if I am changing the braces and if my variable is one and the same, connector is one and the same, that is either disjunction or conjunction, my result is going to be the same. Disjunction, this we have seen recently. Okay. So I hope you have taken the screenshot of this slide and you have written it somewhere. Moving further, the ninth law, law of distribution, distributive law. Here the connectors are different. So if I'm saying there are three prepositional variables P, Q, R, and those are represented using a prepositional statement P conjunction Q disjunction R, I can say that it is logically equivalent with P conjunction Q, disjunction goes outside, P conjunction R. Repeating. P conjunction in bracket Q disjunction R is equivalent with P conjunction Q disjunction with P conjunction R. It is same like saying, if I am saying like this, P multiplied by 5 plus 2. This is equivalent with P multiplied by 5 plus P multiplied by 2. Let us check whether it holds P. 5 plus 2 is 7. 7 threes are 21. So I should have 21 in my LHS. Here 3 5s are 15. 3 2s are 6. 15 plus 6, 21. 21 matches with 21. Here we are saying addition is distributed over multiplication and vice versa. Okay. 3 multiplied by 5. Addition comes outside and again you are putting multiplication inside the bracket. In the similar manner, for discussing, let me go back to my presentation. Where is my presentation? Okay. So I am saying here, conjunction is distributed over disjunction. Here, disjunction is distributed over conjunction. So similar law holds true for disjunction. If you are having a prepositional form like P disjunction in bracket Q conjunction R, it will be logically equivalent with P disjunction Q. Conjunction comes out, P disjunction R. This is known as law of distribution. I hope the thing is clear. Next, law of tautology, law of truthness. Okay, what that law says? P, if we take a disjunction of any prepositional variable, P is just an example. If we are taking disjunction of any prepositional variable with value true, it will be always equivalent with true. Like justification, what will be justification for this statement? How many truth values are possible for P? I could have either true or false. So let me put P instead of P. So if P is having truth value as T, what is the result of P or T? Result is T. If I put here instead of T, if I am putting as false, so if I put here false, what is the result of false or true? Result is always going to be true. So what to remember in short, if we are having true in a disjunction anywhere, your result is going to be true. How come? Because in my table of disjunction, I am going to have all values true except when both of the values are false. So we are interested in only one value as a true for getting our result as true. I am talking about disjunction that may not hold true for conjunction. Okay. The next law is P disjunction false. So I will not say directly it is false. Okay, it depends on the value of P. If P is true and other value is false, if P is true and this one is false, our result is going to be true, which is the value of P. If P is false and this one is also false, false or false, I will have resulting value as P. Whatever we assume for P, that will be the resulting value. Is it fine? समझ सकता 11 12 whether 11 12 are clear? ठीक समझते okay, no problem. Next, what if we replace this disjunction by conjunction? If I'm talking about P conjunction 2, its result will be, let me go back to somewhere so that I will get the answer. So recently we have seen P disjunction 2 is equivalent with, it is equivalent with, let's say equivalent with P or false is equivalent with P. Now my question is, question for you. Otherwise, it would be a thing that you are reading from slide, and that should not happen. Okay? That is the reason why I am taking this. I want your answer. What will be present in the right hand side for this? Oh, okay. What will be present if we say P conjunction T? It will be equivalent with P. Why P? Because if value of P is true, I will say T and T. Result is T. If value of P is false, false and T, the result is false. Okay. What will be here? P conjunction F. If you can say P conjunction F, can anybody tell me in the chat box? Yes. Okay. F. Very nice. Very nice. Very nice. It will be F because irrespective of value of P, if one thing is false, we are obviously going to have result as false in conjunction. While if one thing is true, in case of disjunction, we are going to have final result as true. Very simple, isn't it? While learning this, you are finding it easier, but I'm quite okay sure that while solving the problems, it will create some sort of confusion in your mind. So P and true will result in P. P and false will result in false. What is the disjunction? If I take a disjunction of variable and its negation, it will always be true. How come? If value of P is false, its negation will be true, and we are going to have result of disjunction as true. If value of P is true, its negation will be false. True or false, result is true. That will not hold for conjunction. In case of conjunction, our result, final result will be false. P is T, its negation will be false. So what is T conjunction? False, it will be false. P is false, its negation is true. False conjunction true, result is false. Number 17, so 15, 16 are covered. Number 17 is known as a double negation, negation of negation. If we take negation of negation, we reach at the original statement. So every proposition is equivalent to negation of its negation. Check करू शकता तुम्ही इथे. Let us say value of P is T. Value of P is T, that means its negation is F. Its negation is again T. So negation of negation results in original state. Okay. These are the very prominent laws that you should by heart for solving the further examples. These are something new. This is important. P conditional Q is logically equivalent with negation P or Q. This is very, very important. Okay? And you should be again asking me, how can you justify this? If I want to justify this, I'm going to construct a truth table. I will check out the truth values for P conditional Q and truth values for negation P or Q. I will observe that the truth values are exactly same, hence both are logically equivalent. P conditional Q is logically equivalent with negation P or Q. So take this as an exercise, homework. You should not submit, but for yourself, construct the truth tables for at least these three equivalent statements and check out whether whatever I am saying is correct or not. So you will observe that P conditional Q is logically equivalent with negation P or Q. Secondly, if we take biconditional, I think we have considered this in yesterday's class as well. P biconditional Q is logically equivalent with P conditional Q whole conjunction on Q conditional. And one last statement, P conditional Q is logically equivalent with its contrapositive, which is nothing other than negation Q conditional negation P. Is it fine? Shall we proceed? Have you taken it down in your notebook? Shall we proceed? Shall we proceed? सगळे जागेवर आहेत, जागे आहेत, असं विचारावं लागतं मला. सो आहेत सगळे ठीक, प्रोसेस जण आहे. Okay. So fine. Okay. So let's proceed. Just a quick recap. Okay. Using the following statements, Raju is tall, Raju is strong. What is the symbolic form of the following statement? Raju is tall but weak. The symbolic form will be, this one is represented as P. So, I will say P, and for weak it is opposite of strong. So we will say Q bar. That will be mentioned somewhere on the slide as well. Okay. The statement given is equivalent to Raju is strong and Raju is not strong. So the corresponding symbolic representation is P conjunction negation. Using P and Q of previous question, what is the symbolic representation of this? It is false that whenever this word comes, we have to write negation. It is false that means negation. And whatever comes after it is false that, I am going to put a bracket. Raju is short. That means negation of, this is negation of. See, I am using repeatedly either bar or tilde operator just to make you aware that you can use either. And for strong, we are going to write that statement as negation of, in bracket, negation of P or Q. So you got the statement given. Okay. Now these are the questions for you. Based on the laws, we have to prove this. I will solve this and you are going to tell me the answer for this side by side. Okay. Prove that P or P conjunction in bracket P conditional Q or Q is logically equivalent to P conjunction Q. Remember that here we are not going to use a truth table because truth table method I have already discussed yesterday. We have to now make use of laws of logic for proving this statement. P or P conjunction P conditional Q or Q is logically equivalent to P conjunction Q. Any hints for solving this from your side in the chat box? कसं सॉल्व करता येईल हे परत एकदा इथे दाखवतो तुम्हाला ते प्रेझेंटेशन जस्ट अ सेकंड वी हॅव टू सॉल्व दिस P or P conjunction P conditional Q or Q is logically equivalent to this. Any hint in the chat window so that I could know that we are committed to T. Abhishek is saying committed to T. आहे का अजून आन्सर कोणाचं काही येते का ओनली अभिषेक अदर्स Yash Parkar is saying something interesting. P or P. Idempotence. Okay. Just observe. LHS. This one is LHS. So I'm observing that here P or P. So we are having law of idempotence for disjunction. So P or P can be written as P. Can I write? Yes, it is perfectly fine. I can write P or P as P. That we have seen. So we have to write using law of idempotence. P disjunction P is replaced by P. And here we are observing P conditional Q or Q. I can write for Q or Q. Q. Okay, Q or Q साठी Q लिहिलं. Now we are left with नवीन आपलं एक्सप्रेशन काय झालं आता सध्या P and in bracket P conjunction. As I'm using mouse, okay, that is the reason why we are getting these annotations not in proper format. I'm not using digital pad. So this is the expression that we are getting. This P or P is replaced by P conjunction as it is. Next P as it is conditional. This Q or Q is replaced by Q using law of idempotence. But we have to get only this P and Q. So what can be done further? सांगता येईल ह्याच्या पुढे काय करता येईल P conjunction P conditional Q. How you are going to reduce it further? Prathamesh is saying something. Okay, what? Idempotence. Okay, idempotence is used. Okay. Prathamesh is saying P conditional Q is equal to Q. How? How come? Do we have any rule for P conditional Q is equivalent to Q? If we visit the last slide, okay, you can observe that there is a rule. Rule number 18. P conditional Q is equivalent to negation P or Q. That we have to use in while solving this exam. Okay. So further to this will be replaced by negation of P or Q. This is inside a bracket. ठीक है, हे bracket मध्ये आलो. We are having this in this, and we are having outside P and. So if I further do P conjunction negation of P, what will be result? False. Okay, we will have false result as such. But we need to expand it further. Uh, P conjunction negation P in one bracket using law of distribution or comes outside and in bracket P conjunction Q. So this result P conjunction negation P will be false. Okay, or comes outside P conjunction Q. What is false or P conjunction Q? Everything which is disjunction. Okay, false disjunction P conjunction Q. We will have our result as P conjunction Q. I hope you are getting. समझता था? ठीक है, solve करूँगा. Just a second. Let me take a eraser. नसेल समझ के problem. Mathematical subject है. If it is clear, most comfortable. नसेल चलता. I'm having solution only. So this thing is replaced by this P using law of idempotency. We are left with P conditional. Q or Q is again replaced by single law of idempotency. Further to this entire thing is replaced by negation of P or Q using law number 18. So we are having P conjunction negation P or Q. Further to this, we are having distributive law. So P conjunction negation P. Disjunction goes outside. P and Q. P conjunction Q. I know that P conjunction negation P is always false. That rule we have recently seen. False or P conjunction Q. So again, using rule, P or F is equivalent with P. So we are having F or P conjunction Q is equivalent with P conjunction Q. If anything is not clear, let me know. Carefully look out at the solution of this problem. So first of all, we have taken reduction of two similar statement variables to single using law of idempotency. Further, we are making use of elimination of condition, and thereafter we are making use of distributive law. Is it fine? Just go through this. If it is fine, can you reply in the chat window if it is clear? Can you please reply in chat window? Is there any problem? Anyone? If at all you are having any problem, let me know. No problem at all? Fine. If it is the thing, that's good. That was virtually also discrete maths can be taken. Can you just tell me which rules we need to use for solving this example? This you can consider as an exercise for today. Okay, just note down in your notebook. Can we solve it and obtain logically equivalence for this, if it is possible? P conditional, Q conditional are. So first of all, I will make use of elimination of conditional, rule number 18. This will be equivalent with negation of P or this whole bracket Q conditional R. Again, we will use elimination of conditional for this inner bracket. Okay, so I will say Q conditional R is equivalent with negation Q or R. And further to this, I will again make use of distributive law and again reverse of elimination of conditional to reach out at this table. Jamel Dahe, can you solve this? Morgan, who is saying Morgan? Yes, you would be able to. Okay. So have you noted down this in your notebook? Will you try? This is not assignment. In case you get a solution to this problem, it is optional. You can send me a snapshot on my WhatsApp of the solution to this problem. Optional, totally optional. No, snapshot problem. Okay. Let us proceed. Again, whatever I said. So this P conditional, Q conditional are negation P or negation Q or R, elimination of condition. Now this comes, okay, this is use of associativity. Change of braces doesn't affect the final result. Negation P or negation Q, whole, okay. Again, De Morgan's law. Negation comes outside, that means you will have conjunction inside. Negation in bracket P conjunction Q, whole or with R. And finally, I am using again conditional. So this is nothing other than P conjunction Q conditional R. So I have given you solution as well. So you will not post this as a snap on my WhatsApp. You have to solve this. I will not provide a solution for this question number 5. Note it down in your notebook. You have to prove this. These two are logically equivalent. P conditional Q and P conditional R is logically equivalent with P conditional Q and R. So, note it down somewhere. Take a snapshot. Okay. I hope you have taken that. Okay. Okay. Further, this you are going to solve on your own. Okay. Let us go ahead. There is important and interesting concept in the theory of logic known as a dual of a preposition. So, what is the meaning of dual of a preposition? If we have been given a preposition X, let X be a preposition involving disjunction and conjunction as the connectives, and X star be a preposition obtained from X by replacing or with and with or, T with F and F with T, then X star is known as dual of X. In short, okay, in short, what is dual of a preposition? If we have been given a preposition involving conjunction, disjunction, or true or false, we are simply replacing conjunction by disjunction, disjunction by conjunction, true by false or false by true, then the new form obtained is known as dual form of existing prepositional form. You can observe an example. The dual of negation P or Q, conjunction R is. I'm keeping this bracket as it is. Okay, negation P as it is. Instead of disjunction, you have to put conjunction. Instead of conjunction, you have to put disjunction. You getting what is dual of a preposition? If two prepositions X and Y are equivalent, then their duals X star and Y star are also equivalent. I mean to say, if we are having a preposition like P conditional Q is equivalent to negation P or Q, then their duals will also be equivalent. There will not be any dual for P conditional Q because we can get a dual only for expressions involving disjunction and conjunction. That doesn't hold true for conditional and biconditional. Okay, is it fine? A preposition whose truth value is always true is called tautology and contradiction. This we have seen yesterday. So, again, another set of questions. Okay, we will come back to question number 1 later on. Can you tell me what is the dual value of P conjunction Q or T in the chat window? Something question 2 ची dual value क्या है? Can you tell me in the chat window what is the dual value? Dual value of this. So while computing dual, we have to look for the conjunction disjunction symbol. Simply replace conjunction by disjunction, disjunction by conjunction, replace true by false or false by true. So dual value of this expression will be P will remain as it is. Instead of this, I will have or, I will have Q. Instead of this or, I am going to put conjunction. Instead of true, I am going to put false. So this will be dual of original statement, which was P conjunction Q or F. I hope you are getting. Conjunction is replaced by disjunction. Disjunction is replaced by conjunction. True value is replaced by false. So this is the mechanism of computing a dual value. Did you find? Yes, Atharva Kakade has given the answer. Many of you have. Okay, I have not seen. Thank you. So we are having problems on this. So let us move for the problems. So we have seen recently, I think this is visible. Look, should I make it larger? Okay. So we have seen recently De Morgan's law. Now, and the question is, use De Morgan's laws to find the negation of each of the following statements. So you have been given a first statement, Jan is rich and happy. What will be its negation using De Morgan's law? Any answers in the chat box? Jan is rich and happy. You have to use De Morgan's law. Fast होत असेल तरी सांगा. Okay, if I'm going fast, let me know. So we have to use De Morgan's law, and we need to give a solution in the statement format only. So any answers in the chat box for this? What will be negation of this? I know that and is used. Okay, so if I'm using negation for negation of P and Q is equivalent with negation of P, conjunction becomes disjunction. So what will be our answer? Let P be a statement, Jan is rich. Q be a statement, Jan is happy. So negation of this statement will be Jan is poor or Jan is. You may write like this: Jan is not rich or Jan is not happy. Like this. This is negation using De Morgan's law. So conjunction has been converted into disjunction. All giving the same answer. Jan is poor or Jan is sad. Very good. Jan is not rich or he is not happy. Perfect. What will be the answer for second? Carlos will bicycle or run tomorrow. The answer will be or is now given. Okay. It will be Carlos will not bicycle and will not run tomorrow. Instead of or, you have to put and wherever there is actual sentence, you need to identify the proper place and put a not. So for this, answer will be Carlos will not bicycle. Instead of or, I'm going to put and. I can directly say not run tomorrow, or I may write he. Okay, he will not run tomorrow. So both of the statements will be. So again, take it down as a homework, not your assignment. Okay, this is not assignment. Class exercise. We are doing it. Okay, simultaneously. So Mary walks or takes the bus to class. Its in negation will be Mary doesn't walk and he does not take the bus to class. Negation of this, Ibrahim is smart. Negation will be Ibrahim is not smart or he is not hardworking. So in the similar manner, you may note down these statements and try on your own to solve. Okay. That is the reason why I am halting at this point of time, so that you can at least note down the statements and try. In case you are having problem, you may approach me. So have you noted it down? Is it fine? Shall we proceed? Take this statement somewhere in your notebook and take it as exercise. It's fine. Shall we move ahead? I hope it is fine. Okay. Now, next question is about finding dual of given prepositions. So we have been provided with prepositions P or negation Q. What will be its dual? Any answers in the chat box for first as well as second? What are the duals? P or negation Q? Dual will be P conjunction negation Q. You have to simply replace disjunction by conjunction, false by true or true by false. Fine. So let me know the answer for B and C in the chat box. While answering, you should mention the answer with B. Okay, what is the answer of B? What is the answer of C like this? This is visible, okay. So what will be the answer for B? This is the answer. Okay, what is the answer for B? Answer of B will be B, disjunction. Q, conjunction. R, true becomes false, conjunction becomes disjunction, and vice versa. It is same like seeing yourself in a mirror. The reason why I'm asking you, I want to check out how many of you are really solving and how many of you are simply attending the lecture for the sake of attendance. And C will be P disjunction negation Q. Always remember that in the dual we are not changing negation to original statement or vice versa. We are only making it for conjunction to disjunction, disjunction to conjunction, true to false, and vice versa. Not for other statements. So its dual will be P disjunction negation of Q whole conjunction Q disjunction false. You can again take a snapshot of this and try on your own. Try करून बघायचे. Questions have been asked in the examination for 2 to 4 marks. They will give you similar set of statements and ask you to find dual. Very easy and scoring subject. I hope you have taken a snapshot of this. Have you taken up? Assumption I. Yes, have you taken? Okay, Omkar, you can do it later. Okay, Omkar showing. And others as well. You can do it later. Correct. Your answer is correct. I said that just take it down somewhere and try to solve it afterwards. Again, the technique to write the answers in examination. Okay, if the same question is present in the university exam, are you going to write it like this? What is your justification for this? Are you going to write like this in the exam, in your final exams? You should not. Okay, if you are using this approach and if I am evaluating your paper, I will not give you a single mark. So how to write a solution for any of such question? So if this is given, you should first write definition of dual. Even though it is not asked, it is required. Okay? You should write it first, and then you will write we have to replace by and in given statement. Hence, answer is B, disjunction negation. This is the way in which I am expecting the answers for each and every question in each of. Okay, if you are writing like this, you will not get a single one. I need a definition of dual written everywhere whenever there is a question in the examination. Is it fine? Okay, next one. Okay. So, you know. Moving further to this. Okay. Now, can you tell me which of the following is true about the proposition P conjunction negation P or Q? Yes, this will be logically correlated with C. Let's check out. The proposition can be written as we have been given. So we can make use of distributive law. Using distributive law, this can be written as P conjunction negation P or comes outside P and Q. This one is false. So false or P conjunction Q. I'm having this. This we have seen already, isn't it? What is dual of this? The dual of any expression is created by replacing or with and so on. So this is the dual of distributive. Okay. Which of the preposition is a tautology? So out of this, you have been given, no? There are two ways to solve this problem. The first method is drawing truth table. You have to draw a truth table for all the four expressions and thereby find the tautology. The approach becomes time and space consuming. So what is the alternative? By making the given expression of the form T or an expression where T is known as tautology. So we will see that approach for this. So observe that I can write this option A as P or Q conditional P by eliminating the conditional. So that can be written as negation of P or Q or so you are observing negation of P or Q or P. As I am observing that here, we cannot further decompose it into tautology T. So there is no tautology. Option B, P disjunction Q conditional P. This can be also written using by making use of elimination of conditional. But we could observe that we cannot further decompose it to true. Hence, this is not also a tautology. Option C, P disjunction P conditional Q. We are observing that P disjunction for this we are replacing by negation P or Q. So again, while making use of law of distribution, not exactly distribution, I am simply using associativity where change of basis doesn't affect the final result. So P or negation P or P or Q. So for this P or negation P, we are getting true. True or with any expression will result in true. Hence, this is tautology. So what is this approach? The second approach is we have to make use of given expressions, their convergence using the laws of logic and try to check out whether you are getting a single expression of the form true or an expression. If you are going to convert the given statement in this format, true or given expression, then we could simply say that T is known as tautology. I hope this clears. Okay. Moving further. Let X denotes P or Q conditional R and Y denotes P conditional R or Q conditional R. Which of the following is a tautology? This is the question for you. Observe carefully. Let X denotes P or Q conditional R. Y denotes P conditional R disjunction Q conditional R. Which of these options is a tautology? By using method number 2, that is converting to true, it will not be possible. So we will be drawing the truth tables for all of the given options in this case. Are you following? Answer represented. Let me show you. So for this, okay. X is what? X is P or Q conditional R. Okay. P or Q conditional R. So F true, FT true, TT true, TT true, TF here I could observe the result. So for X as well as Y, the truth table has been constructed. Then we are constructing the truth table for negation Y as well according to the requirements of the options. Then we are computing X by conditional Y, X conditional Y, Y conditional X, negation of Y conditional X, and so on. Okay. Finally, for checking out tautology, we could observe that all the entries in the column of x conditional y are all true. Hence, x conditional y, the statement B is a tautology. Clear? I hope this clears. Whatever I will discuss in the later sections. Is it fine? Is it comfortable? Yes. Any problems so far? Any problems? N9. Are you going to N9? No. No. Okay. I am aware that you are continuously attending the fourth lecture of mine, and I will not take much of your time. So that's it for today. If you are not having any difficulties, just turn on your mic so that, sorry, video cams so that I can mark your attendance and we will stop for today. Uh, do not miss tomorrow's morning lecture because important concepts like finding conjunctive normal form and disjunctive normal form CNF and DNF will be discussed in detail in tomorrow's lecture. Okay. So for this time, turn on your video cams and let us stop for today. Large, Atharva, then you should use some problem. Okay, Omkar Shivani, Sejal Sindhu, Prathamesh, your cam is off. Vaibhav Gaikwad, attending from? Okay, Prathamesh cam is off. Swapnil Parandi, okay, Punika, okay. I should also turn on my cam, isn't it? Using PC, Rohan. Okay, okay. Rohan, if it is, if there is any problem at your end, it is perfectly fine. Okay. Anyone else would like to switch on the cam? Mansi is saying webcam is not available. Okay, Kinaya available. Okay. Anyone else? Okay, Atharva. Okay, Prachi. Anurag. Okay, Prachi. Anurag Bhusle. Then who else? Sunny Bhoi. Abhishek Bhoi. Okay. Aditya. Who is Shraddha. Okay. Anurag Bhusle. Okay. Fine. Thank you. Thank you for attending today's lecture. Have a nice time. Good day.